So good day, my dear STEM students. For today, we'll be discussing all about Dalton's partial pressure. Okay, so in Dalton's partial pressure, it involves the different pressure exerted of the different gas substances. Okay, so in Dalton's law of partial pressure, the pressure exerted by each gas is called the partial pressure of the gas. The total number or the total pressure of the mixture of the gases is the sum of the partial pressure of all the gas present. Okay, so in calculating for the partial pressure using the mole fraction of the gas mixture, this is the mathematical equation that is being used. Okay, so P sub I is equal to X sub I times P sub T, wherein P sub I is the partial pressure and then X sub I is the mole fraction. Then the mole fraction, you can calculate the mole fraction using this mathematical equation. X sub I is equal to N sub I divided by the total number of moles. Okay, N stands for the total number of moles or the number of moles. And then P sub T is the total pressure in atmospheric pressure. So we abbreviate atmospheric pressure as ATM. Okay, so for our first sample problem, a mixture of gases in a closed vessel contains 4.46 moles of neon, 0.74 moles of argon, and 2.15 moles of xenon. Calculate the partial pressure of the three gases if the total pressure is 2.0 atm at a certain temperature. So the first thing to do, since we have three gases, we need to calculate first the mole fraction of each gas. Okay, so the mole fraction of neon is equal to the moles of neon. So given siya sa problem, so the moles of neon is 4.46 moles, then divided by the total number of moles. So you have to calculate or add up all the mole value given. So what are those? So 4.46 moles plus 0.74 moles and 2.15 moles. If you add that, you will get the value of 7.35 moles. So yan ang gagamitin natin in this part of the mathematical equation. That is the total number of moles. Okay? And then for the mole fraction of neon, so 4.46 moles divided by the total number of moles, then cancel the unit of mole, and then you will get the value of 0.607. Then step 2 is to calculate the partial pressure of neon using this equation. Okay, so the partial pressure of neon is equal to the mole fraction of neon times the total number of pressure. So the total number of pressure, ito siya. Okay, so given siya sa problem, which is 2.0 atm. So you have to multiply that to get the partial pressure of 1.25 atmospheric pressure. Okay, so do the same with argon and xenon. So for argon, so the number of moles of argon is 0.74 divided by 7.35. Then cancel the units. Then you will get the value of 0.10. Then compute for the partial pressure being exerted by argon. Then you will get 0.10 times 2.0. So yan yung given sa problem. So the partial pressure of argon is 0.20 atm. Then next, the partial pressure of xenon. Okay, so 2.15 moles divided by 7.35 moles. Cancel the mole unit and you will get the value of 0.293. Then calculate for the partial pressure of neon. That is 0.293 times 2.0. Then you will get the partial pressure of 0.585. The sum of the partial pressure is equal to the total pressure. Okay, the total pressure is equal to P sub 1, P sub 2 plus P sub 3, P sub 4, and so on. Okay, so 1.21 atm plus 0.20, okay, plus 0.585. Then if you add that, you will get the total number of pressure of 2.0 atm. Okay, kaya yun yung total number of pressure. Parang checking nyo na rin ito. Okay, pwede nyo siyang gamitin as checking. Kapag hindi nyo na, pag tinotal nyo yung number of pressure, tapos hindi naman yun ang lumabas na value, so you have to recheck your mathematical solution. Baka there's something wrong with the procedure. Okay, so calculating the partial pressure using the ideal gas equation. You already know some of the different gas laws kasi that is we have discussed to you during your junior years in high school. So for today, we'll be using the ideal gas equation in calculating for the partial pressure. Okay, this is another formula, but this time you will be using the ideal gas equation. So a 10-liter flask contains 0.200 moles of methane, 0.300 moles of hydrogen gas, and 0.400 moles of nitrogen gas at 25 degrees Celsius. Okay, what is the total pressure in atm of the mixture of the gases? And then B, what is the partial pressure of each component of gases? So what are the givens? So for our volume, the volume is 10.0. Okay? So, kung ano yung container, so ang gases kasi assume the volume of its container. So, if the volume of the container is 20 ml, so the volume of the gas is also 20 ml. So, if the volume of the container contains 1 liter, so the volume of that particular gas inside the empty vessel is also 1 liter. So, yun ang ginagamit natin kasi nga gas siya, hindi niyo naman siya nakikita. So, kung ano yung size ng container, ano yung volume ng container, yun na mismo yung volume ng gas inside that particular vessel. So, and then take note, if you're using the volume, you have to be particular with the units being used in volume. So, for gases, lagi siyang naka-liter. Okay? So, liter lagi ang ginagamit na volume. So, if other units of volume are given, so for example, cubic centimeter or ml, you have to convert that to liters before you use the ideal gas equation. Okay, so for temperature, we have 25 degrees Celsius, but you have to convert that to Kelvin also. So that is the basic rule in using the ideal gas equation. All temperature reading must be converted to Kelvin. So dun pa lang sa given, mag-add na kayo ng 273. Actually, the exact value of the Kelvin constant is 273.15. That is the exact value. Okay? Pero ngayon, ang gagamitin lang muna natin is 273 para wala muna kayong decimal point. Okay? Then, next. So for the R is the universal gas constant. The value of this number or constant is 0.0821 and the unit is liter atmosphere per mole Kelvin. So as you can see, all the units in the universal gas constant is in liter and in the Kelvin scale. So all temperature and volume reading must be in those units in order for those units to be canceled out in the mathematical procedure. Okay, so the number of moles, we have three types of gases. So we have the value for the moles of those three types of gases. Then i-add nyo na siya dyan pa lang para you get the total number of moles which is 0.900 moles. Okay, so this 0.900 moles, so is the total number of moles of these three gases. Okay, and then the unknown is the total pressure. Okay, the total pressure in atm. Okay, calculate the total pressure first. Okay, the total pressure being exerted kasi kanina doon sa isang klase ng mathematical equation natin, given na kagad yung total number of pressure, you need to have that particular value in order for you to compute for the partial pressure of the three gases. Okay? So, kailangan meron kayong total pressure. And to calculate the total number of pressure of this mathematical problem, we will be using the ideal gas equation, which is the PV equal to nRT. Okay, so our unknown is the total pressure in atmospheric pressure. So, pag nag-equate naman kayo or tawag dito yung nagde-derived kayo ng formula. So, pag ganito naman yung equation ninyo, madali lang naman yan kahit hindi na kayo maggawa pa ng any mathematical procedure. Basta tatandaan nyo kung ano yung tabi ng unknown, siya kagad yung denominator. Okay? So, the final equation that you will be using is P is equal to nRT over V. Kasi tabi ni V, si pressure. So, kung ano tabi ng unknown, siya yung denominator to get the final formula. Okay? So, this is a simple way of deriving formula. Pero I know that you have your own style in deriving mathematical equation. Pero that is the easy way in deriving the ideal gas equation. Kung ano tabi ng unknown, siya yung ilagay nyo sa denominator. Okay? Next, so P is equal to 0.900 moles. So we will be computing now for the total pressure being exerted by the three gases in the 10.0 liter flask. Okay, and then multiply by the universal gas constant, which is 0.0821 liter atmosphere per mole Kelvin times the temperature. So susundin lang natin, diba? We have the mole, we have the universal gas constant, and we have the temperature all over the volume, which is 10 liters. And then perform the mathematical operation. So in the numerator, if you multiply that, but before doing that, you have to cancel all unwanted unit kasi ang kailangan lang nating matira dyan is the unit for pressure, which is atmospheric pressure. Okay? Yan liter. And then, ang end unit natin, yung natira is ATM. And then, if you will multiply all those three values, you will get 22.0 ATM divided by 10. And then, the total pressure of these three gases is 2.20 ATM. That is the total pressure. And then next, for B, the partial pressure of each gas in the mixture can be calculated by substituting the number of moles of each gas individually. So, isa-isa niyong kukumputin yung tatlo into the ideal gas equation. So, you will be using the three values of moles, and then you will be computing for the partial pressure using the PV is equal to nRT, or the ideal gas equation. So for methane, we have the number of moles of methane is 0.200. This is the original number of moles of methane, okay, in the given problem. So this is individually. You will not be using the 0.900 moles kasi yun yung total. Ito, kinukompute natin siya as partial pressure. Okay? Kaya you will use the individual value of mole, not the total value of mole. So, 0.200 moles, okay? Okay, following the PVNRT, then cancel all the unwanted units, and you will get 0.489 atmospheric pressure. Okay, then you will divide that to 10, and then the partial pressure of methane is 0.89 atm. Okay, let us proceed to hydrogen gas. Okay, so hydrogen gas has a mole value of 0.300 moles multiplied by the universal gas constant and the temperature in Kelvin divided by the volume of the container. Then cancel all unwanted units. Then you will get 7.34 atmospheric pressure divided by 10.0, and then the partial pressure of hydrogen gas in the vessel or in the 10-liter container is 0.734 atm. Okay, so for nitrogen gas, so we have 0.400 moles multiplied by the universal gas constant, and the temperature divided by the volume of the vessel or the container. Cancel all units, all unwanted units, and then so for the numerator, if you multiply all those three values, you will get 9.79 atmospheric pressure divided by 10. And then you will get 0.979 atm. And then for checking, if you add all the partial pressure of the three gases, you will get the total pressure of 2.20 atmospheric pressure. Okay, so if you have any questions with regards to the Dalton's law of partial pressure, just leave your questions in our Google Classroom, or you can directly give me a message in our group chat. Okay, so stay safe, stay healthy, and God bless everybody. Thank you.